Let's go to see the exercises for chapter 5. Let's start with multiple choice 1. A experiment is a process that generates well-defined outcomes. So the correct answer is D. For number 2, we know that the summation of the probabilities has to be equal to 1. So the missing probability will be 2 over 5. So the correct answer is B. Let's go to move on with problem number 1. The sample size is 100. So this is your N. What is the probability to have blood type A plus? So the answer is going to be 34 over 100 or 0.34. Problem number 2, what is the probability of not selecting a person with blood type B plus? So probability not to have a blood type of B plus will be 1 minus the probability to have a blood type of B plus. We have 10 people. So in this case, the probability will be 1 minus 10 over 100, which is 90 over 100, or 0.9. So this is the solution for problem number 1. Let's go on to move on with problem number 2. In this case, we have to work with cards. So we have a card that is drawn from a standard deck of cards. We have 52 cards. So keep in mind, this is going to be your N. What is the probability that you have a 10 or a heart? Probability to have a 10 or a heart. This is the same as the probability to have a 10 plus the probability to have a heart minus the probability to have a 10 and heart. So the probability to have a 10 will be 4 over 52 plus the probability to have a heart, which is going to be 13 over 52, minus the probability to have a 10 heart, which is going to be 1 over 52. So for this problem, the answer is going to be 16 over 52, or 0.308. Next one, what is the probability to have a 7 or queen? Keep in mind, you don't have a card that is 7 and queen, so that will be the probability to have a 7 plus the probability to have a queen. So this is going to be equal to 4 over 52 plus 4 over 52, which is the same as 8 over 52, or 0.154. What is the probability to have a red or diamond? Keep in mind, we have it in the PowerPoint slides that diamonds are red. So this is going to be the same as the probability to have a red plus the probability to have a diamond minus the probability to have a red and diamond. So this is 26 over 52 plus 13 over 52 minus 13 over 52. After you do the calculations, this is 26 over 52, or 0.5. Next problem, problem number 3. We have to work with dice. Don't forget that we have a total of 36 possible outcomes because we have 2 dice and we have the outcomes for this problem. So what is the probability to get to numbers whose summation is less than 6? So summation to be less than 6 This is the same as the summation to be equal to 5 plus the summation to be equal to 2. So we have to check the outcomes. We're going to have 10 outcomes. For example, for 5, as you can see, you have the 3 and 2, the 2 and 3, 1 and 4, then you have the 4 and 1, and so on. So in this case, the probability to have a summation of 5 will be 4 over 36, plus the summation to be equal to 4, 3 over 36, plus 2 over 36, plus 1 over 36. So this is the same as 10 over 36. Probability, the summation to be greater than 10. So in this case, you look for the probability, the summation to be equal to 11 plus the summation to be equal to 12. For 11, we have two outcomes, 5, 6, and 6, 5. So 2 over 36. Plus, for 12, we have 6 and 6. Only one outcome. So the answer is 3 over 36. And for the last problem, probability the summation to be 5 or 6. Already we know for 5, the probability is 4 over 36. We know that from the previous problem. Plus the probability to have a 6 will be 5 over 36. It will be 3, 3, 4, 2, 2, 4, 5, 1, and 1, 5. So 5 over 36, this is the same as 9 over 36. So this is the problem with the dice. Let's move on now with the last two problems, which is based on the table. So let's go to see problem number 4. As soon as we have a table, step 1 is to calculate the total. We have 400 undergraduate students, 100 graduate students. We have 200 business. We have 175 engineering, and then we have 125 arts and sciences for a total of 500. So what is the probability to have a business graduate student? Here it is, we have 50 students. So 50 over 500, which is equal to 0.1. What is the probability to have an undergrad or engineering? We have to check the probability to have an undergrad student. So if you check undergrad is 400 over 500, plus the probability to have an engineering, 175 over 500, minus the point of intersection. For this problem, the point of intersection will be 150, because we count this number twice, one for undergraduates and one for engineering. So we have to subtract the point of intersection. As soon as you do this calculation, this is 425 over 500, which is the same as 0.85. Next one, what is the probability to have a business or arts and sciences? Business or arts and science. We don't have any point of intersection. We have to check how many business we have. We have 200 students majoring in business. So 200 over 500, plus we have another 125 that are majoring in arts and science. This is the 200, this is the 125. So the answer is 325 over 500, which is 0.65. We have to follow the same steps for the last problem. We have to calculate the total first. We have 120 males, 80 females, 50 single, 150 married, for a total of 200. So what is the probability to have a male or single? The probability to have a male will be 120 over 200 plus the probability to have a single will be 50 over 200, and then we have the point of intersection male single, which is 20, and we have to subtract this number. So as soon as we do the calculation, this is 150 over 200, which is 0.75. And the last one, what is the probability to have a female single customer? In this case, we have to examine how many single female customers we have. We have 30 of them, so 30 over 200, which is the same as 0.15. And these are the problems for chapter 5.